How's it going, Adam? Is it giving? How's it going, Adam? Is it giving? How's it going, Adam? Wala, nandito na si Jules Padilla.
Excited na ako mag-review.
Thank you for your excitement.
Well, yes. Okay. Well, yes. Okay. Well, no. Well, sort of, kind of.
Where are these sound effects coming from?
It's the soundboard. Oh, the delay is so
That's
delayful.
That's so cool, but that is crazy.
I need to clean up my desktop. Hold on. sorry. Well, yes. Okay. Where are we? Let's open this and this. Hello. Hi, Crystal Biro. Avert your eyes. Yeah. Well, yes. Oh my god, 8 o'clock na pala. Shall we wait? We will wait. Am I audible? Is it clear? Is it yummy? Anyone? Is that an affirmative response? Okay. Thank you for your affirmative response. Okay, I'm gonna pop this out. Pop like this. Da, da, da. How long should I wait, guys? Let's take a vote. Who's this? Hi, Henry Romy. I'm just kidding about the vote, by the way, don't worry.
I think we can start mga 8:05.
Okay. Guys, I'm feeling the pressure. And unregistered. Okay. Bruh. But be so for real. Eh. No, it's so ugly. Hold on. Let me restart this. We still have time. It's 8:05. So I guess let's start. Okay, hold on. I have notes for this. Okay, so to start off, I just want to say thank you for being here. Oh, okay, so let's all get ready for our LE3 in IE27. The thing I noticed from the samplex, if it's reflective, representative of what our LE3 is actually gonna be, the style is really gonna be a bit different from the LE1 and LE2, which for some people can be a good thing, it can be a bad thing. Pero ayan. So it's a bit different, but there will still be some applications of past units, unfortunately. So like, no, di niyo pa pwede i-delete yung LE1 and LE2 sa brain niya. So before I start off with the samplex, if anyone has any specific questions about the topic or anything, we can start with those. Kasi honestly, medyo the thing with this is it's kind of just plug and play na formulas for most items. So very brute force lang ang review session natin today. So if anyone has any questions before we start the brute force, you can go ahead. I will give it 5 seconds. 5, 4, 3, 2, 1. Okay. So I assume we're ready to to move on with the samplex. If there's anyone chatting sa thingy, Marielle or someone else, please voice na lang because I am not tapping out to check the chat because I'm sharing my whole screen. Anyway, so I decided to start with number 5, the problem solving, because the first few items, the first part is true or false, and then the first few items is super like yun nga, sa plug-in lang and then making the graphs and stuff. So I feel like we can just leave that for if we have time to go over it. So these are the more solving, the problem solving. So our first item, Psycho number 5, Psycho Publishing has released a new book para sa nagmamahal ng one-sided. Apparently, printing has not been excellent. There were reports of numerous books with several defective pages. Quality Control Department inspected a total of 100 books and recorded the number of defective pages in each. The data they gathered is shown below. They deemed it appropriate to model the number of defective pages per book as a Poisson distribution. So ayun nga, may Poisson bigla, even if LE1 pa yun. So first, let's just take note of our important stuff. The 100 books, and that it's a Poisson distribution. So the first sub-question is pretty easy. It's just asking, what is the best point estimator to use in estimating population mean? So really, this isn't even like, ay, ba't may unregistered na naman? Basta, watermark lang yan. Kita niyo naman yung drawings. So, this question isn't like specific to the problem. It's actually just a question on its own. And the answer is sample mean. Yay! Okay. So, letter B, estimate the population mean. So, since we established none and the best point estimator for estimating the population mean is the sample mean, what we're gonna do is we're just gonna get the sample mean. So, for this one, to get the mean, we just do it like we usually do. So we have our x values and then their frequency. And then the sample mean is gonna be the sum of basically the expected x, which we learned in LE1. So the sum of xi times fi all over n, which is our sample size. We established it to be 100. Let's just write that here so it's clear. N equals 100. And then if you add that all up, which I have a calculator, but I also have the answer key. So we know which one's faster. I'm just going to check the answer key. Okay. The answer is 2.96. And our nice little step app, Zed, gave us some tips with our calculator because our wait, I don't know what kind of calculator you guys have, but chances are you have one with stat capabilities. So if you can take out your calculator right now. And then we're gonna find the stat function, which will make our life a lot easier. So you're gonna go to menu, what's the name? Menu, and then statistics. I wish I could stream my calculator too. I'm sorry, guys, but I hope you can follow. Menu, and then statistics, and then one variable. And then if you get a table and it just says X, then, and you don't have like the frequency column, you can also get the frequency column. First, go back to like the start page, go shift and then menu to set up. And then scroll down, go to statistics and turn on frequency. Then I really hope you guys are following these instructions. But basically, what's gonna happen is when you are able to enable these, or when you're able to access these functions, it's gonna automatically solve for the commonly asked stuff like the mean, the standard deviation, the max, the min, the Q1, the median, the Q2. It's not all of that. It's gonna be matic. Like the standard deviation also has it has population standard deviation and sample. Like it shows the solution, the answer for both kinds of standard deviation. So, ayan. If you have questions about that, just ask away because that's really important and it will be a big time saver. So, then letter C, let's move on. Sorry, I'm such a yapper, no? Okay. Letter C, estimate the population variance using the population mean point estimate. So this one is basically you can rephrase it in your head as, or the first thing you want to do is find an equation for the variance in terms of the population mean point estimate, or in other words, in terms of the mean. And then you won't be able to do this anywhere else except this specific kind of problem because it's a Poisson problem. And if you remember the unit 1 for Poisson, the mean or the expected value of x is equal to lambda, and the variance is also equal to lambda. So actually, the variance is equal to the expected value, which is the mean. So when they say estimate the population variance using the population mean point estimate, what you're just doing is equating it. So our estimate for our population variance is equal to the mean, which is estimated to be 2.96. The letter D. Sana nag-gets. Wait, let's box our final answers like very, very responsible workers. Letter D. What's the question? So letter D. Estimate the population variance using the sample data. So this is where you're gonna use the usual formula, like yung brute force, x minus x bar, or the mean, tama na, squared all over, ano yun? N. So if you solve for this, hold on. Population variance using the sample. Let me check the answer key. Okay, tama. Tama naman. Okay, so basically we're getting the sample variance, since sample variance is a point estimator for the population variance. And then again, you can manually solve this using this data, or you can input it into this one variable calculator ng one variable thingy ng calculator niya sa statistics, and then it will give you the answer straight up, which is 3.0784. Then letter E, the question is there a significant difference between the 2-point estimates for population variance? Which of the two is a more accurate point estimate? Okay, I won't write this out now, I'll just speak it. So this one is kind of like subjective / conceptual question. So Is there a significant difference? Not really, but that's really just like you're eyeballing it. 2.96, not that far off from 3.0784. So that's how we say there's not really a significant difference. And then when we're asking which one is a more accurate point estimate, is that a question or is that a different server? I think that's a different server. I'm so sorry, guys. If it's a question, someone unmute na lang and read it. Thank you. What was I saying? So which one is a more accurate point estimate? The one we got in C or the one we got in D? So the answer here, according to the answer key, which makes sense to me naman, is in this case, because the problem includes a Poisson, it concerns a Poisson distribution. The one in letter B is actually more accurate compared to the one that we get in D. Because I think you can think of it similar to like in physics lab. I think we've all taken physics lab. If you remember, there's parang yung margin of error, basta yung plus minus, ganon. Basically, the more operations you do with measurements that you're not sure of, the more room for error there is. So since when we computed for the sample variance, we have this x minus x bar, that's my squared pa tayo. There's a lot more room for error compared to the operations we do in getting the sample mean. Yeah, in this specific case, since the sample variance, or since the variance is equal to the mean in a Poisson distribution, we can actually rely more on the estimate from the sample mean. And then letter F. What is the standard error of the point estimator for sample mean? You notice it's 1 point. That's because it's just plug and play again. So standard error for sample mean, there's a formula for this, which is standard deviation of the population over square root of n. Or if you don't know, if you don't know the standard deviation or variance of the population, you can use the sample variance over square root of n. And then in this case, we know our sample variance. We have two values for it, but since we said na our sample mean is more accurate for it, let's do square root of, yes, because this is the variance. So square root of 2.96 is the standard deviation. And then divide by square root of Rn, which is 100. Then the answer you're going to get here, according to the answer key, is 0.17205. So that's it for number 5. Any questions? I'm going to check the chat real quick in case. Man. Okay. If we're ready to move on, send a heart graph. Oh. Miko Pascual is typing. Go, Miko Pascual. Okay, how to input in the calculator. Mag-uncam na lang ako. Wait lang. Let me set this shit up. Oh, sorry. Not the bad word, guys. That was so scandalous. Oh, don't look at this. Hi, guys. Ang dilim pala dito. Okay. So, kita ba? Oh no. Flashlight na lang ako. Okay, this was a terrible idea. I'm not gonna lie to you guys. This was not very efficient. Hold on. I gotta turn on my lights first. Okay. Hello. So, actually, I can move my camera down. Does this work? Okay. If you guys have a calculator like mine, does it look good? Is it mirrored or di naman? So you press menu, then you go to the stat one. You can use your arrows to go to the stat, or you can press the 6, And then here, choose one variable. Wow. So, ayan. There's the X, and then there's also a frequency column. You literally just you input everything in there. Okay, let's use the actual data. And then I will show you. Hold on. This is so logistically confusing. Hold on. 0, 1, 2, 3, 7, 8, 9, 10. I'm so sorry, guys. I don't know what this looks like from your perspective or how this feels like staring at the blank screen. Okay, so now I've entered all of the data. It's here. Yung 1, 0 to 10, and then the frequencies. And then you press option. That I can't see. Press option. That's my options here. Press 3, 1 variable calc. And then it's gonna show you everything. And sorry, it's kind of blurry. It says here, holy cow. Basta, andun yung mga values. Yung X bar, it's 2.96 like we computed over here. Tapos yung, where is this? Yung sigma squared X is 3.0784 like we computed also. So, ayan yan. Nagets ba? That was so messy. I'm so sorry. I can send pictures like later after nito. Unless. Thank you though. Are you sure, Vika? Okay lang yan. Okay. That's what I was saying. Is this, or do you also have the Casio Keme? The same calculator? Because if you press shift and then menu, my setup done, you scroll down, then crash yung thing. And then press statistics. And then it asks if you want to turn on frequency. Oh, spooky. Okay, let's get back to number 6 as soon as it reconnects, which hopefully it does. Yeah. Okay. Number 6. So our number 6 is the effects. Wait lang. I'll full screen this muna since we're not using the formulas yet. Okay. The effect of Cobra Energy Drink. So let's highlight important details as we go. 50 workers, that's our sample size, were put to study to determine if there is an effect on productivity if they were given Cobra Energy Drink to consume. Productivity is measured in terms of the number of widgets assembled per worker. During the controlled setup, they were not given any Cobra Energy Drink. The number of widgets assembled per worker in the setup had a mean of 200 units, highlight, with a standard deviation of 10 units. During the manipulated setup, they were given Cobra Energy Drink. The number of widgets assembled per worker in the setup had a mean of 225 units and a standard deviation of 8 units. Hold on. I'll drink some water while I let this information sit. Okay. So our first question, what is the expected effect on productivity due to Cobra Energy Drink in widgets assembled per worker? So before we do anything, we can list down all the information, all are given, just so we know. And let's have our X bar 1, meaning the mean before the Cobra Energy Drink, be 200, standard deviation 1 equals 10, X bar 2 equals 225, standard deviation 2 equals 8. So what is the expected effect on productivity? So when we say expected effect, basically, paano nagbago yung productivity? So this is actually, we're gonna make our another random variable, which is a linear combination. of the means before and after. So our random variable, which is the effect, I guess, is equal to the x bar 2 minus x bar 1. I'm not sure if my bar pa dapat, but you get the logic. x2 minus x1 because, yun yung change in production. So what is the expected effect on productivity due to? So since expected, we're just going to get E of y. And if you remember linear combinations from LE1, yeah, LE1, it's going to be the expected x2 minus, yeah, so I put no bar here, I think, minus the expected x1, which is basically the same of these. Well, not basically the same, because these are the point estimates for these. So that's what we are using. So this is just literally going to be two. Oh, sorry, I pointed the wrong arrows. So this is this, and this is this. Going to be 225 minus 200. Going to be 25. Then letter B. Let's move this letter A. What is the standard deviation of the effect on productivity due to Cobra energy drink? So, standard deviation. We're also basically may pagka linear combination siya ulit. So, first, since we don't do linear combinations on the standard deviation, let's find the variance first and then just square root it. So the variance is going to be, if you want to be technical about it, it's 1 squared times the variance of x2 plus 1 squared, or I guess plus negative 1 squared times the variance of x1. Insert that brackets. Oh no. Okay. And then in this case, since what we have right now is the sample variance, according to the answer key, what we're gonna do first is we'll get the standard error. Well, not it's the standard error squared, which is kind of like variance also. So our variance of x2 will be equal to, put a bar here, our variance of x2 over 50. Because this, sorry, I forgot to put the formula. Basically, v of bar is going to be equal to v of x all over n, because this is related to the standard error from kanina, yung standard deviation over square root of n, basically. So then our answer here from v variance of x2, we just substitute as an n. Okay, for x2, we're gonna get the itong 8, then it's gonna be 8 squared because 8 is a standard deviation over 50, which is equal, oh, ano ba yun? Okay, yeah. 8 squared over 50 is equal to 1.28, and then v of x1, which is 10 squared over 50, going to be equal to 2 because that's just 100 over 50. So now that we have these, our variance of y equal to 1.28. Oh my god, running out of space. Let's move up. 1.28 plus 2 plus 3.28. So our standard deviation, or tama ba yung symbol na ginamit ka? Let's say, yeah, our standard deviation from the square root of 3.28, which is 1.8111. Honestly, there's something I'm not sure about dun sa item na yun. But we're learning together. I'm gonna confirm pa with my teacher, my prof, and then I will get back to you guys if you care, if you even care. But according to the answer key, that's how we solve it. So let's go back to move on. Go back to move on with letter C. I had to make some space. Okay, letter C. What is the probability that the effect on productivity due to Cobra Energy drink to a sample of 50 workers caused them to produce 30 units more each? So this is where we're gonna apply. This is basically an application of central limit theorem tapos yung normal distribution that we learned from LE2. So since central limit theorem says like for large samples larger than 30 or at least 30 since we have 50, the distribution of the sample means, not the data itself, the distribution of the means is going to be normal. So basically what we're looking for here is the probability that the sample mean of a sample will be greater than 30. There's also something a bit wrong with the phrasing here since it says 30 units more, but I guess we can just pretend it says at least 30 units more. But if it says that, maybe we can say it's zero kasi, equal and it's continuous. But ayun, so at least 30 units more. So the probability that the sample mean is greater than 30. And we're going to apply. Asa na tayo? Okay. We're gonna find the z-score first ng 30 since we know the mean na. The mean is, where did I write it? 25. Sorry. So since this is the effect pala, let's be more specific. Let's say this is y bar greater than 30. And since the mean of y is 25 and the standard deviation of y is 1.8111, let's just solve this like this were a continuous distribution problem from LE2 given these parameters. Yeah. Okay, so let's find the z-score first. It's gonna be equal to 30 minus 25 over 1.8111. If you plug this into your calculator, it's going to be 2.76. So our probability that y bar is going to be greater than 30 is basically the same as the as 1 minus the probability or yung CDF ng normal of 2.76, which if we look for our table, 2.76, ay, naka-highlight na. Spoiler, guys. 0.76 is 0.997110. Sorry, let's add our 1 minus. So the answer is going to be 2.00288. Or, sorry, let's round to 4 decimal places. 29. Okay. Any questions? Send a heart if you don't have questions. In case you guys are. Oh. Thank you, Shania. Ang dami mong heart. Thank you. Okay. So I think we can move on to number 7 first. Dami kong ebas, no? Okay. Number 27. 27. Number 7. So this is where we're gonna start making intervals. So we have to whip out this formula sheet. According to Sir Earl, itong gray yung formula sheet. But I'm still gonna confirm with him if kasama ito, which is the prediction interval. But for sure, these ones are gonna be part. But I'm not sure if they're gonna be labeled. I'll also ask that. So, ayan. Thankfully, my formula sheet na tayo in this world. So, let's start with number 7. So 35 typists were observed to determine the length of time it takes to type a whole document containing 5 pages. Their times are recorded below. So let's just highlight 35 typists. That's our ano yun? Sample size. Yeah. Okay. So construct a 95% two-sided confidence interval on the mean time to type a document containing 5 pages. So we have to find first what formula are we going to use from here. 95% two-sided confidence interval on the mean. So we're going to get from this block. Then we don't know the distribution. Wala namang sinabi if it's normal or not. So let's go immediately down to the third row. Unknown distribution, unknown variance. Okay. Unknown distribution, unknown variance, but it's a large sample size. So based on this flowchart pala, we can actually use yung z-score. So the formula we're going to use is the first one, or the second one. Yes, the second one. Since even if we don't know the distribution, since n is greater than 30, parang we assume na lang na it's normal, we can use the z-scores. So itong second row. Let's write down the formula dun sa second row. So our boundaries, the boundaries of our confidence interval are going to be x bar plus minus z of alpha over 2 s over square root of n. So let's solve for all of those individual things first before we get to writing the actual confidence interval. So we need our x bar. We can input everything into our calculator. Like I showed before, sana may calculator kaya. But I mean, it's okay because I'm gonna show you the answer anyway. So if we input all of these data into our calculators, or if you manually calculate the mean x bar, let me put this down. Find that x bar is equal to 37.60343, and then our s is equal to 8.75850. And if you count all of the data, you'll know that n is equal to 35. Yeah, that one. And then for the z, we're looking for z of alpha over 2. Since it's a 95% confidence interval, our alpha is equal to 5%. So alpha over 2 is going to be equal to 0.025. And we can check our normal tables for this, or if you're awesome, you'll know na 0.025 is one of the common na for the confidence thing. So pwede mo na lang i-memorize na the z-score for that is 1.96. So we have everything we need, basically. So we'll solve for x bar minus z of 0.025 times s over square root of n. It's going to be equal to 34.70173. So I think starting here, you're going to get what I mean when it's just a lot of it is just going to be plugging in. And then our x bar plus z 0.025 times the square root of n equal to 40.0. 50512. So from these, our confidence interval is 35.7017 and then 40.5051. Hooray! So, again, I need to move this down again for space. There's not any questions about this letter A. Where do I write A? We can move on to letter B. So letter B is basically the same thing. Construct a 90% two-sided confidence interval on the mean time to type a document containing 5 pages. So we're gonna do everything the same. The only thing that's gonna be different is the z-score. Kasi iba na yung alpha. The alpha is gonna be 0.1. So alpha over 2 is 0.5. Oof. So we're gonna do everything the same except that the z is 1.64. So if you calculate those, you find that the lower bound is 35.17548. Upper bound is 40.03138. If you got lost, we're just using the same formula, yung ito, x bar plus the z-score times the sample standard deviation over the square root of n. Okay. And we can move to C, which is another conceptual question. So I'm just going to yap about it. I won't write it. So your question is, which of the two previously constructed confidence intervals is bigger and why? So if you want to mathematically check it, you can find the difference or the range of this mean. Tama. The range of, no, not tama. What the hell? The range of this interval, you just subtract the big from the small, 5.80 something, and then this one, 4.856. Sorry, kind of random decimal places. Anyway, so you're gonna find that the 90. Wait, baliktad ba? I know, no, that makes sense. Okay, this is the 95% interval. This is the 90% interval. So when they ask you why, kind of a weird question, but I guess you just explain how it makes sense to you. So for me, why it makes sense is that's basically how confidence intervals work. That's like the trade-off between the confidence and the range or like the width of the interval. So yung 95%, you're more confident kasi mas malaki yung sakop sakop ng interval mo. So since you're covering more and you're more confident na in that interval is your thingy, the sample mean, the population mean. So then vice versa for the 90% confidence interval. Mas maliit yung interval. Like, so you can say you're more specific, but the trade-off is you're less confident. So basically, like all other things constant, higher confidence level means a bigger interval. Wow. Okay. Letter D. A typist is overqualified if he or she can type a whole document containing 5 pages in less than 25 minutes. Construct a 95% two-sided confidence interval on the proportion of overqualified typists. So, if you're like me, kanina when I read this question for the first time, I was a bit confused. But if you see yung proportion here, that's our keyword that gives you a hint on how to solve this one. So it's really just a proportion of proportion as in there are two kinds of people. People who can write a 5-page document in less than 25 minutes and people who can't. So you just count how many people how many of these in the sample are less than 25. So let's count. There's one. Oh my god, my highlighter's so big. There's another. Then sorry about that. Okay. So there's another one, 24.89, 23, 24. So if you count 1, 2, 3, parang may na-miss ako. I'm gonna go Dora mode if I can't find it, guys. There, 24.06. So there are 1, 2, 3, 4, 5, 6. Out of the sample, 6 of these have a time less than 25 minutes. So our point estimate for the proportion is just going to be 6 out of 35, because this is x over n. And then, ano yung hinahanap again? There, at 95% two-sided confidence interval. So let's just use our formula. So we have our proportion here. Let's check the formula. For the boundaries is p plus minus the z-score over 2 times this big thing, p 1 minus p over n. Okay. Whew. Okay. Okay, sorry, I skipped a step. Well, not like a step. The thing about a lot of these is there's assumptions you have to make to use some of these formulas. So our assumption for proportion intervals is that the sample size is big enough to be assumed as normal. And you're gonna check lang if np is greater than or equal to 5, and if n times 1 minus p is greater than or equal to 5. Since rp is 6 over 35, rn is 35, we just know our np is 6. Then since r1 minus p is bigger than rp, we know that's gonna be bigger than 5 anyway. Okay, so ayan. That's just confirming that what we're gonna do is applicable or appropriate. So from here, we just plug in. So 6 over 35 plus minus, oh, sorry, less than 95%. So our z alpha over 2 is 1.96 again. 1.96 times square root of 6 over 35 times, 29 over 35 over Rn of 35. 35. So once you plug these in, you'll find that our confidence interval for the proportion is 0.0466, 0.2963. Yay! I hope everyone is following. Then letter E. Construct a 95% two-sided confidence interval on the number of overqualified typists in a sample of 35 typists. So when you're asking for the number instead of the proportion, you're just gonna multiply it by the given, since this is just 35. Multiply both of these by 35. And you do that, you're gonna get something like 0, 4, 6, 6, 7, 35. It's gonna be like 1.631, 0.2960 times 35. This is gonna be 10.3705. Then you just estimate this. Wait, what does it say again? I think it says it specifies to round off. So you're gonna make this 2 and then 10. This is the answer lang sa answer key. But I'm not sure if this 10 should be rounded down or should turn into 11. But I will confirm again with our instructor. But I think the logic here is you want to make the confidence interval smaller. Right? So I think in the answer key they use typical rounding rules. But ayun, baka dapat 11 nga. Because our instructor, Sir Earl, parang this whole unit, he always says to round up. So this might be 210, this might be 211. I will get back one day. But since it specifically says to round off, I feel like it's valid din naman to use typical rounding rules. Because it doesn't say round up. Sorry, super technicality. But ayun. Let's move on to number 8. If everyone is ready. Show me your heart if you're ready to move on. While I'm fixing the format nito. Thank you for your hearts, everyone. I feel so touched. Okay. Right. A restaurant is using a filling machine to serve customers. Oops, sorry. Ayan. It's using a filling machine to serve customers with cups of soft drink beverages with a supposedly fixed volume. During closing hours, the manager tested if the filling machine is working properly. In other words, if the standard deviation of fill volume exceeds 0.64. Let's highlight that. Then an unacceptably large percentage of servings will be inaccurately filled. The manager tested the filling machine 15 times. 15 times. And got the following data. Assume filling volume is normally distributed. So let's just, what we know right now is n equals 15, and then this whole data. You can insert that data into your calculator. But thankfully, I already have the answer, so I don't have to do all that. Okay, so the first question. Construct a 95% two-sided confidence interval on the variance of fill volume. So when it comes to variance, when you sorry, the kind of interval you're gonna use is obviously ito, yung variance. It's the only one. There's no other kind of variance interval. So you're gonna see the formula. You're gonna be using the chi-squared. Then a prerequisite to using the chi-squared distribution is the population has to be normal. And then if I am okay, here it's given naman, assume that the filling volume is normally distributed. So since it was given in the problem that the population is normally distributed, we can say na applicable naman yung chi-squared. Chi-squared, sorry, not chi. Chi-squared distribution when we use it to make our intervals. Yeah. So let's write our formula again. It's a lot of formulas, right, guys? N minus 1 times s squared all over the chi-squared of alpha over 2. Degrees of freedom is n minus 1. Tapos, same thing, but with the negative alpha over, not alpha, not negative, 1 minus, sorry, 1 minus alpha over 2 and minus 1. Okay, so let's find all of these first. The first thing we can solve for, or actually the only thing we really need to solve for, solve for, is the standard deviation, variance na pala yan because it's s squared. The variance of the sample, which is, okay, hold on. Bakit S yung binigay dito? So it says it's 2.12652. And let's just square it. That's S squared. And this is our S squared. And then let's find our lambda squared. Our alpha is 0.05. So alpha over 2 is 0.025. N minus 1 is 14. And then let's be ready to find the other one. The chi-squared of 0.975 at 14 also. Let's check our table. Ito ba yan? Oh, that's the distribution. Okay. 0.025 at 14 degrees of freedom. 26.12. Assume 0.975. 5.63. Hope everyone's still following. And then since we know our n minus 1. Hold on. Let me double check the formula. Okay. Since we know our n minus 1, we know our s squared na rin. We just substitute into this formula. So what you're going to get is 2.4238. 11.2450. Okay pa guys. Since a lot of it is kind of just substitution and then you having faith in me na tama naman yung input. I hope you're able to follow nonetheless. Letter B. Construct a 95% two-sided confidence interval on the standard deviation of fill volume. So for this one, since you already made a variance interval, you just need to square root the bounds. 2.42 blah 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 for 11.25 blah blah blah. You're gonna get is 1.5569 3.3534. Let's box the other one din pala. So that was simple. Now you move to letter C. Construct a 95% one-sided lower bound on the variance of fill volume. I don't know why. Why are they doing this to us? So it's a one-sided. So we just look at this one-sided lower bound. So it's literally there. The one-sided lower bound is n minus 1 s squared squared alpha. Hindi na siya divided by 2 kasi it's one-sided lang. And then minus 1. So wait lang. Let's find this first. Our chi-squared 0.0514. Yeah, 14. Just gonna be equal to 14, 0.05, 23.68. Oops. 23.68. And substitute again, you're gonna find that the lower bound is equal to 2.67354. So since it's one-sided interval, you can't make it in what's it called? Basta you can't use this notation. So just do 2.67354 less than or equal to the variance. Oof. And you can use this notation din naman for every other interval we've done, like less than or equal to, less than or equal to, ganun. But I just prefer yung brackets. Anyway, this one, I'm pretty sure this is a typo, not variance. This is also standard deviation. So, yung sagot said D, you just square root it also. Or the answer to, the way you answer D by square rooting the answer in C is what I mean. So square root of 2.67354. What you're gonna get is just 1.6351 less than or equal to sigma. And then just answer E, which is analysis. Is the filling machine working properly? Why or why not? And then the answer is just that no, it's not working properly. Kasi the lower bound of the standard deviation, since we're 95% confident na the actual standard deviation is above 1.6351, but our limit dapat is 0.64 lang. The answer is no. Ang layo nate. Like 1.63 from 0.64. Okay. So that's it for number 8. Any question? Show me your heart. Relax. If you want to continue on with this life. What? If you're ready to move on. Okay. Ah, so let's continue with number 9. Goddamn, guys. This is a lot. And this is only like half of the sampling. 14 observations were done. Let's highlight that. That's the sample size. We're done for the inter-arrival time of customers entering the family park. Wait, hold on. Okay. Below are the results. Assume the inter-arrival time of customers to be normally distributed. Yay. I love assuming things. Okay. So again, we have another data table, which we're just gonna stuff into our calculators to give us free answers. Construct a 95% prediction interval on the time until the next customer arrives. So since it told us to assume normal distribution, I'm not sure. Di ko pa na-check. But I think that probably means na yung assumption for prediction interval is dapat normally distributed siya. Okay. So let's construct a 95% prediction interval on the time until the next customer arrives. So first, let's lift out this formula. So the prediction interval is, the bounds are going to be x bar plus minus. The t score, would that be the word? Yeah, t score at n minus 1 times s times square root of 1 plus 1 over n. Yeah, that's a lot. Am I right, guys? So let's just make sure we're clear now. Our n is equal to 14. Our alpha is equal to 0.05. Our s, this one you're going to get from either manually calculating or letting your calculator calculate the sample standard deviation, which we're going to find out 2.05939. Thank you. So, sorry, let's find the t-scores first. So t of alpha over 2, which is 0.025 at n minus 1, which is 13. So let's find it. Oops, wrong tab. Still the wrong tab. Okay, just freedom 13. Alpha over 2 is 0.025. So this is equal to 0.2, 2.160. Let's make this nice. So, guys, pagod na ako mag-substitute. Oh, I forgot to also solve for x bar. But the calculator is going to do that for us anyway, guys. Robots are the slaves of humans forever and ever, which is 5.8136. So now that we have all of these values, which are going to be in the formula here, can substitute lang. The interval is going to be 1.2092 10.41 or 180. Hooray! Okay. Okay. Letter B. Assume the next customer arrives with an inter-arrival time equal to the previous sample mean. Construct a new 95% prediction interval on the time until another customer arrives. So, in significance of the next customer arriving, are basically we have more data sa dataset natin. So our n is going to become n plus 1. So our new n is 15. But our x bar is equal to, it's still the same because when you add something to the dataset, which is equal to the mean, pareho lang. As far as I know. Yeah, tama naman. I hope. And yeah, true. It's true, guys. And then you're still gonna need to add it sa dataset niyo sa calculator because even though the mean stays the same, the standard deviation won't. It'll actually lower kasi, you know, you're adding a data thing which is, wait, tama ba yun? Yeah, you're adding it to the mean, so it will get squishier. Actually, I'm not sure if that's true. Sorry, guys, I'm just spouting fake news. But it makes sense to me. Because if the new data is at the mean naman, it's not like an outlier. So, hindi siya mag-contribute to making the data more spread out. Ganun. I'm saying? So, this is our new thingies. N equals 15, x bar equals 5 point blah, 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 blah. Alpha is still 0.05. And then we need to find another t-score because we have a new n. So our degrees of freedom changed. So the t is t from 0 at 14 because n minus 1, 15 minus 1. 15 minus 1 is 14. Who would have not? Who would have thought? Okay, 2.145 is the new t-score. So again, you substitute lang from this formula. Also the same formula as here. Then you should get, wait, why am I putting an arrow? 1.4173 and 0.2099 bucks. Then the next question. Is the new prediction interval smaller or bigger? And why? You can solve for it again. 95 prediction interval for the 15th one is, or the length is 9.2. The length for this one is 8.8. So obviously the next one, the later one has a smaller interval than if for the y, it's why ba? Okay. It's mostly because we have a new data point, right? We already know what time the 15th customer came in. So since we have more data to go off of, we're more confident in our estimation of the 16th one. Kasi I think that's related to law of large numbers, but not really. Mas analogous. Since you have a bigger sample size, parang mas sure ka na your data is representative of what's gonna happen next, or like your data can be used to predict what's gonna happen next. So, and yeah, since the meaning of a smaller confidence interval means na smaller siya, so you can be more precise. You're being more precise with your prediction because you believe na with more data, you can be more confident in having a smaller interval than before. Gets ba? Sana. So that's it for the word problems na I feel that we needed to discuss, but there's more word problems. There's 10, so how many did we do? 1, 2, 3, 4, 5. 5, 6, 7, 8, 9. So we did 50% of the word problem. But let's take a break first. When we get back, we can start from the start, starting from the true or false. I think you guys will want to see the true or false din naman, and then the rest of the word problems if kasha pa. And we will start again by what do you think, Maria? 9:15. Heck yeah. 9:15. Okay, 9:15. See you guys later. Hi guys. Oh, I have to reconnect. How was your day? While I'm reconnecting. Oh my god. Thank you everyone. My day was also. Sorry. Reconnecting to the thingy. Actually, do I even need to? Parang di na ako oh wait, no, I do have something to draw. I'm a liar. Huh. Sino sumali? Si Shai Olivares. Sorry, I'm trying to connect my iPad again. Pero ayaw na niya. Aww. Hold on. Let me restart it. Of course. That's our direct or something. Community development. Tama ba? Okay. Ito. Ito ba yan? Okay. True or false? So now we're starting over again. Like Sarah Geronimo said. Si Sarah Geronimo ba yun? I don't know. Anyway. So number 1. Statistics is, given the information of a sample, describe the population. Easily, this is true. Huwag niyo na i-overthink. Yeah, that's literally like probably the first slide of the unit na pinakita sa inyo. It's true, it's true. Okay. Letter B. Systematic random sampling is a non-probability sampling technique. Answer is false. Kasi nga, random na nga siya. So, it's a probability sampling technique kasi random siya. Or, okay, false. There are outliers in a dataset. Trimmed mean is a more accurate statistical measure of central tendency. Answer is true. Kasi trimmed mean. Do I need to explain all of this? Anyway, I'm sorry. Let's make this a worthwhile engagement. So I will explain. Trimmed mean, basically, trimmed mean is usually trimmed by a certain percent, meaning you're gonna remove or like you won't include the highest that percent and the lowest that percent of the data set in your calculation for the mean. So if there are outliers, hindi sila i-include sa calculation for the mean. So the outliers will not like hindi mahahatak ng outliers yung mean. So it will be a more accurate central tendency measure. Okay. Sample median is an unbiased point estimator for population mean. Again, our lovely step up said, because he's from stat. So sample median, the weird thing is sa I-27 slides natin and in the answer key, this is true. Sample median is an unbiased point estimator for population mean. But I think perhaps a higher statistics, if you're getting more specific with it, technically it's false. Or it's only true if the data set is symmetrical. Because when the data set is symmetrical, then the median is equal to the mean. Sana alam niyo yan. Because you can see it naman sa graphs and stuff. So I think the answer here, for purposes of IE27, parang true yung sagot. But in practice, false talaga siya. So, okay, moving on. Letter E. Sample standard deviation is an unbiased point estimator for population standard deviation. Answer here is false. Honestly, I don't really know why. Pero false lang talaga siya. Like, it's in the slides. Like we have sample mean, sample variance, sample standard deviation. those are all unbiased estimators of their respective parameter. Yung exception is standard deviation, which is not an unbiased point estimator for the population standard deviation. Okay. Central limit theorem states that for large sample sizes, even if the probability distribution of the population is unknown, the samples taken from it follow a normal distribution. So this is false. Don't believe in those lies. So this is a bit of a tricky one, because the central limit theorem states that even if the probability distribution of the population is unknown for a large sample, it's the distribution, okay, the sample means are what follow a normal distribution, not the sample data set itself, but the distribution of the sample means that you could get from multiple different samples, multiple random samples. Gets ba yun? I feel like this is one of the central limit theorem. It's giving the vibe ng parang kunwari gets nyo. But then you just accept it. Parang yung, what was it? Yung intermediate value theorem and mean value theorem. These theorems, man. So, sana gets nyo. It's the means that follow a normal distribution, not the samples themselves. And then if you want samples that follow a normal distribution, dapat the population, sorry, let me phrase that better. Not really related to this item, but it's just a fact. If the population is normally distributed, the samples you get will also be normally distributed. Sorry, inuubo ata ako. I'm going to die now, guys. Okay, G. The t distribution is more prone to produce values far from the mean than the normal distribution. This one is true. I feel like pwede rin to i-overthink. But, the reason is pretty simple. It's because the t distribution is not the normal distribution. It's only approximated to be normal. So, the values that you're gonna produce are more far removed from the actual values kasi approximation nga lang siya. Okay. The length of a confidence interval is a random variable. This is true. So, remember the length of a confidence interval is yung the upper interval minus the lower interval. And if you go, sana di rinig yung sound sa labas, but if it is, okay. Anyway, if you go to all these formulas, yung x bar minus yung x bar, yung s, and yung p, those are the random variables in this formula. I'm not sure if I missed any, but basically the point is, since the boundaries of a confidence interval are calculated using random variables, the confidence interval, the bounds are a random interval, a random variable, which also means that the length of the interval is a random variable. So ang daming random. It's like a chain of events. Basically, since you got the confidence interval from data which is produced from a random sample, the interval itself may pagka-random na rin siya. Amen. Okay. Letter I. A 90% confidence interval on mean constructed from a randomly taken sample means that the true value of mu is within the bounds of the confidence interval with a probability of 90%. False. Hold on. Gotta sip my water for this one. So, yung letter I, this is one of the oddly specific, what's the word? Basta details about this topic na it's mentioned in the slides, and they will be particular about it. Like if may sinabi kang mali when it comes to this phrasing, you might get deducted for it. So, yung interpretation of confidence intervals is let's see. You are 95% confident na the confidence interval contains the true value of mu, or 90 pala to. Basta the whatever confidence level. Another phrasing could be 90% of all confidence intervals will contain the value of mu, the true value of mu. So the problem with using probability here, kasi this isn't something that was taught in class in IA 27, but like sinabi lang sa amin in high school, and I think tumatak sa akin, is the mu kasi. Mu is the population mean, right? So since it's from a fixed data set, mu itself is not a random variable. So a good way, or not exactly a good way, one way you can think about it is the reason we avoid using the word probability when it comes to interpreting confidence intervals is since mu is a fixed value. The probability that mu is inside the interval is, it's not, you won't think about it in, it shouldn't be in terms of probability because it's only yes or no, because mu is already fixed. It's either 1 or 0, you know? Hindi siya like, it's not up to chance. It just is. Gets ba? That's why we avoid using probability, the word probability, when interpreting confidence intervals. So again, yung phrasings you can use: 90% of all confidence intervals will contain the true value, or we, ano yun? We can say with 90% confidence that the interval contains the true value of mu. But do not say probability. Do not say probability. Don't say chance. Confidence, or 90% of all intervals. Yun. For large sample, sorry, moving on, letter J. For large sample sizes with unknown population distribution and unknown population variance, the Z distribution is used to estimate population mean because large sample sizes allow the population variance to be approximated by sample variance. Sorry. This one is true. Hold on. No population distribution. We say population mean. Okay. Honestly, I don't know what to say about this. Basta true siya. Z distribution is used to estimate. Ah, okay. True siya basically because since you can estimate the sample variance, since you can estimate the population variance to be the sample variance, this is related to yung kanina. Asan na yun? Did I delete it? Okay, I deleted it. Basta the yung flow chart na whether you should use the T distribution or the Z distribution. If you know the variance of the population, you can use the Z distribution agad. Yun lang. Okay, moving on. So that's it for true or false. So we're gonna go back to the problem solving na whew, medyo, what do you call it? Actually, I'll use the answer key kasi my drawings na siya. But sorry guys. Oh my god. Let me close the stream first while I look for it. Anyway, so the next few items is just yun nga, yung figures and stuff you're gonna calculate for the dimensions of the box plot and all that. Hold on. Let me get this. Hold on. Have to restart it again. Okay, I'm back. So, number 2, given below is an ogive describing the duration of college relationships in months from a particular fictional study. Note you can pinpoint the values indicated in the line graph. So, honestly, I hope we don't have items like these. Actually, pwede na rin. They're easier, but they're not that fun. So, first, let's just draw lines here so we can estimate yung values here. Oh, maybe that's already on the line. Okay. So, if you guys don't know what an ogive is, pero nasa slides na naman yan. It's a line na the ogive itself describes yung. Okay, hold on. Let me label na lang the axes. It's hard to explain it with words. So this is the frequency. And this is the yung values. Ganun. So ogive is cumulative. So basically, for example, at this point at 5, basically what it's saying is this number, we just have to estimate what it is. We can estimate it to be like 2 because it's less than half of 0 to 5. 0 to 5 is 2.5. So let's say it's 2. So basically from this data set, there are two data, two data points na the value is less than or equal to 5. Then the same thing here. This point means na in the data set, there are oops, there are 5 or 4, sorry, estimated to be 4 data points na the value is less than or equal to 9. So you can interpret it all the way up here. But the point is that this is cumulative. So itong 4 na less than or equal to 9 already includes the 2 na less than or equal to 5. So that's why the ogive is, you're able to use it to make the cumulative frequency distribution table, which is this long thing over here, which is, I think, nasa slides naman din. So just familiarize yourself with this format because there's a chance that we'll need to write the entire table. So that's where they're able to get the data points because the ogive itself is cumulative. Helpful siya sa paggawa ng cumulative frequency distribution table. So first of all, the cells. The cells here are made based on yung points. So this is, wait. Hindi naman kailangan 1 to 5 to eh. Okay, because the cell length is 4. The gap here is 4. So that's why it's 1 to 5. Then 5 to 9, 9 to 13. They're basing it on the gaps between the data points. That's what they use for the cells. Then Fi is the frequency. So again, we estimated for this one, it's 2. At least the laser pointer. We estimated for 1 to 5, the frequency is 2. We estimated for 5 to 9, the frequency is 4. Or for the data point at 9, the frequency is 4. But that already includes yung ito sa baba, yung 5. So we did 4 minus 2, we got 2. Then the same estimation all the way to the top. Let's say this last data point, 29. This is 20, frequency of 23. But then it subtracted everything else, but it subtracted the last one here. the last data point was a 20. And then since the last data point had a frequency of 20, so yung 29 na may frequency of 23, you do 23 minus 20. Kaya they say na the frequency in the last one, in the last cell is 3. Kasi 23 minus 20. Then itong relative Fi, that's just Fi. This is Fi over n. And then less than or equal. This less than or equal to CFD. Ito yung you can kind of just straight up copy the data points kasi that's the meaning of an ogive. So since this is 2, became 2, this one is 4, 4. Then yung greater than or equal to, it's just the backwards. Or the backwards? You get the population and then isa-subtract mo yung kasama. Kasama. So basically our n is equal to, what is our n equal to? 23. So for the lowest CFD, or sorry, for the lowest cell, the amount of data points which are greater than or equal to, since it's the lowest, it's the entire data set na. So the whole sample, just 23. And then itong 21, it's just 23 minus this 2 from the first cell. And 19, it's just 21 minus this 2 from the second cell. So, and the thing about the CFD is the columns have like relationships with each other. Pwede mo nang subtract na lang so that you can get the next values, the preceding values. And then, something to note, something you can use to make sure na possible naman yung frequency table mo is for the first cell, this one, yung greater than or equal to, this should be equal to n. Then for the last cell, the less than or equal to should also be equal to n. I think you can reason out why. So based on that, yung relative CFD for the first one, the greater than should be equal to 1. Equal to 1. And then for the last cell, the less than or equal to should be equal to 1. And the rest, sana tama na lang yung kinalculate mo. Okay. Letter B, draw the histogram with frequency polygon from which the ogive came from. So what you're going to use here is basically, ito lang. Tama ba? Yeah, this part. You have your cells and then the frequency. So you make your bars. Tapos yung frequency polygon, all you need for frequency polygon is, it's like that. The points that you're gonna connect are the midpoints of the tops of the bars. You guys, super normal. This one, oh my god. Super calculation ito. So this one is something that you can insert na lang the whole data set, then you'll get the answers. You'll get this one, you get this one. But the one that you can't get from the calculator, you really have to manual it. This one, coefficient of skewness, coefficient of peakness. So just remember the formula for skewness, coefficient of skewness. What's this? The summation of x minus x bar cubed all over n minus 1 times s cubed. Coefficient of peakness, same thing, but what's it called? To the power of 4. N minus 1 to the 4. So maniwala na lang kayo na this is the answer for letter C. You're gonna get a negative answer. So if your coefficient of skewness is negative, your data set is skewed to the left. If your coefficient is positive, it's skewed to the right. Tapos yung itong leptokurtic or platykurtic. This is leptokurtic is greater than 3, less than 3. Tapos yung normal peakness is equal to 3. Do you remember the difference between this? I guess itong leptokurtic lep, it leaped up. So yun yung higher. Tapos yung platykurtic, siya yung flat. So hindi siya masyadong peak kasi it's flat. Thank you. Here. This is the text ng yung kanina. The one where you can just insert it. Okay. Sana nakita niya na. Even I explained it kanina with visual aid. With visual aid. Then number 4. Wait lang. Okay. Number 4. So there's a lot of data here. So you would want to use this tip. Kasi when you use this one variable calc, you're gonna get the 5-number summary agad. 5-number summary. If you forgot or you don't know, and that's the minimum, the Q1, the Q2, the Q3, and the max. And if you think about it, this is like technically minimum is kind of like Q0, max is kind of like Q4. So yung 5-point summary is just the Qs. And then range is, I'm basically reiterating all the formulas. Kaya skinip ko to at first kasi medyo boring. Range is just max minus min. Let's just review the formulas for now. This is how we're ending it, guys. Range equals max minus min. IQR equals Q3 minus Q1. And don't forget na Q2 is the same thing as the median. I don't know how important that will be, but it's just a fact. So when you make a box plot, actually low-key, hindi pa nga to complete unless wala talagang outliers. So this is the box is made of, this is the Q2 or the median. This is the Q1, the Q3. And assuming there's no outliers, this is the minimum, this is the maximum. And then on the other one, basically in case you forgot, the rule for outliers is if from the edges of the box, if it's more than 1.5 interquartile ranges away. So let's say if xi is greater than Q3 plus 1.5 IQR, it's an outlier. And then if it's less than Q1 minus 1.5 IQR, it's an outlier. Tas meron ding extreme outliers, which is, it's the same thing except it's 3 IQR. 3 IQR. Basta ganun. And then, in the case that you do have outliers, these lines are gonna be, you don't put the lines on the boundary. The line should be on for the top one, the biggest value, then not an outlier. And then under the the smallest value, then not an outlier. That's the outliers after are just denoted by points. Let's look at the slides, guys. Box plot. Wrong slides. Here. Okay, so the outliers are dots. And then extreme outliers are parang stars, asterisk, plus. Basta differentiate them na draw whatever you want as long as they are labeled appropriately. Okay. And then Let's see. Letter D. What can you say about the heights of students from different colleges? Give a comparative analysis of the samples. Note on the convergence of values and the spread of data. So, you can just look here na itong CHK. Mas mataas talaga yung student height compared to Eng. Sana not true, but probably true because they have all the basketball players. Anyway, uh, so that's basically one of the conclusions you can make. CHK generally has taller students kasi yung nasa loob ng IQR, that's oomph. That's most of the students na. If I'm not mistaken, wait, Q3 minus Q1, that should be 50% ata. Tama ba? Someone confirm if you can. But it makes sense to me. The one inside the IQR is already 50% of the student population. Tama ba yun? Data points inside IQR are 50%. Sorry guys, I'm just blatantly Googling in front of you guys now. Yeah, it's the middle half of your data. Tama. I'm so good at this, guys. The IQR describes the middle 50% of values when ordered from lowest to higher. Okay, let's move on. Okay, we did 5 na. 1, 2, 3, 4, 5. Tatapusin talaga natin. Oh my god. So that means the last one is number 10. Actually, ang daming sinabi here because, I don't know. This is another kind of item I hope we don't get. But so it's creating a sampling pan. Mukbang's Chicken Restaurant is one of the 3 top quick service restaurants in the country. The current bestsellers are Chicken McDuck's with rice, McDuck's Chicken Filet a la King, and Big McDuck's Burger. Currently, their sales are booming. Wait, let's highlight that. Their sales are booming because of their 2 latest endorsers. And then, blah, blah. The little team called Aldab. McDuck's has 500 stores nationwide, divided among 5 major marketing areas. North Luzon, da 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 da. Okay. You're hired by McDuck's Chicken Restaurant as a marketing analyst. The chief marketing officer wanted to study their market, therefore gave you the specific task to gather statistics about their customers. There are 4 main questions the chief marketing officer wants answered. What percentage of our customers prefer chicken McDuck's rice over the other bestsellers? Is the average annual family income of customers, and is there a correlation between annual family income and preference of chicken McDuck's with rice? What percentage of our customers are fans of Aldo? Okay. So from letter A, usually, since it's just asking what percentage of our customers prefer chicken McDuck with rice over the other bestsellers, or you could just make it like, what is your favorite? But the problem is, ito, is there a correlation between annual family income and preference of chicken McDucks with rice? So since we're going to want to calculate correlation, we won't actually have to do it. The thing is, you need it to be numerical then. So, okay, sorry, I kind of skipped ahead. Let's just start with the sampling plan first. Multi-stage sampling. So you can do stratified sampling to make sure that you cover each marketing area, because it's going to be kind of scuffed if your data is only from North Luzon or your data is only from NCR. So the point of stratified sampling is to ensure that there is data from every strata. In this case, our strata are the marketing areas. And then the next one is the convenience sampling. I'm not sure if this would count as a convenience sampling. I think there's a way that you can do random sampling within branches. But the problem is it's kind of up to the customer if they're gonna answer. Kaya may pagka-convenience sampling din siya. Because you just have to hope that they answer. Or like, yeah. Get ito. Give questionnaires to random customers at random times. It's also convenient sampling, I guess, kasi at the you won't cover everyone who is a customer at that branch kasi there's a chance that they won't come to the store. So yeah, the difference between non-probability and probability sampling is in non-probability sampling, there are some data na has zero chance of being picked. So ayan, since you're only gonna be doing the survey within the restaurant, those who aren't in the restaurant at the time don't have the chance to be picked. Okay. So the survey form would be to rate the bestsellers from 1 to 10. And then see this answer. I mean, hold on. Hmm. Okay. Okay. I think because the answer key was commented on by our step up also in a stat. But honestly, I think medyo may something wrong din sa comments niya. I think another solution here is you could still push through with asking if what their favorite is. Tapos yung kukunin mo is for the correlation of family income and preference of chicken mukbang with rice is the proportion of those in a certain income bracket or of certain income bracket na their favorite is chicken mukbang with rice. Guys, honestly, I'm confusing myself. I think we can end it now. There's a reason I didn't include this item in the ones that we wanted to focus on because it's kind of a crazy item. I sort of hope that we don't get an item like this. I'm a 23s like most of y'all. What else do we have? Yeah. So honestly, most of this is MLI. I think we can't discuss it that much here because there's not that much solving to do. You just have to know the concepts. Let me just check my notes if I have anything else to tell you guys. Okay. Okay. Nakover ko naman lahat. Except super scuffed yung pag-cover ko sa number 10. I'm so sorry, guys. Does anyone have any other questions before we all get out of here? And I can stop streaming. If you don't
While
have
waiting for
questions,
questions, I'd like to remind all of you guys to please answer the feedback form because it will count as your attendance. Also, we kind of changed where you can access the recording of today's meeting. So you can access the recording of today's meeting also in that feedback form. So yeah, make sure to answer it. Thank you.
my T is typing. Ay, wow. No form, no recording. That's crazy. Anyway, so if you don't have questions, send hearts na. But if you have any questions later on, ask me again at a later time. Pag mas naaral ko na to. But I hope na from what I was able to study so far, may natutunan naman kayo. hope this helps. Okay. Good night, guys. Alis na kayo. Thank you for coming. But yes, you're free to leave.
Thank you, guys.